Streptococcus is a gram-positive bacteria. Primary infections of the Streptococcus typically in the oral and nasal area, as you can see here. Okay, we call acute pharyngitis, right? Strep infection, typically. And oftentimes what you can see is that as a result of strep infection, you can have secondary infection or non-infectious complication that result from that. All right? And this non-infectious complication, of course, that is associated with rheumatic fever, right? And we saw that how your immune response produces the antibody toward streptococcus, but because there are self-antigen that very similar to what is shown in the streptococcus, right? And these antigens are found in the mitral valve, and then so the antibody also attacking the mitral valves to get to mitral valve prolapse, so we call that rheumatic fever, okay? Vulvulitis, or the mitral valve prolapse. Okay. Valvular refers to the valve. Okay. The streptococcus that associate with the skin is known as impetigoes, and impetigoes is typically it's brown oozing, crusted lesion, if you will. That is known as impetigo. Okay. Children might have it and show it in the upper lips and so forth. In some cases, the bacteria can also lead to strep infection, leads to meningitis, or when they get into the blood, we already talked about how they might develop a condition known as septicemia. And sepsis is part of septicemia. That's when you get inflammations throughout the body. Okay. Sometimes with the strep infections, you might have where rashes occurs in the arm, for example. In this case, we consider this as scarlet fever. Okay, and scarlet fever is due to it is a skin lesion, but it's caused by the bacteria exotoxin. Okay, so what's the difference between different kinds of toxin? So exotoxin versus endotoxin. Okay. So exotoxin is what the bacteria produce. Okay, they produce and they secrete it, which those protein particles in general, they say, oh, it's heat labile. So in other words, if you heat it up, these protein will denature and it doesn't work as well. Okay, so exotoxins are what bacteria made and secreted. They're considered as a heat labile protein, right? Now, on the other hand, endotoxin is not what the bacteria made and secreted. It is protein that, or I shouldn't say protein, substance endotoxins that are resistant to heat. Example is LPS, also known as lipopolysaccharide. It is part of the bacterial um, cell's membrane, if you will, LPS. LPS, we now know that is can trigger the complement cascade via the alternative system. I don't know if I talked to you about how activation of the complement cascade through either the classical pathway, which is mediated by antibody, versus a non the complement system, which is basically part of the proteins that we have in our body called BDP that activates the complement system. The BDP is actually is activated by LPS. Okay. And so usually because of that activations of the complement system, LPS, there that you might have what we consider as sepsis maybe arising, and that is inflammation throughout the body that leads to vasodilation, that could lead to hypovolumetric shock, and that's the danger due to this endotoxin as opposed to exotoxin. Okay, so not only just strep, but other gram-negative bacteria that could develop septicemia, and they can produce this, and when they dead, they produce this endotoxin. So note the difference between endotoxin versus exotoxin. Okay. All right. Now, typically, bacteria that is invading the GI tract, a lot of these are gram-negative bacteria. Okay. This doesn't show you very well, but certainly there are viruses that can cause the gastrointestinal tract infection, or parasite like Giardia. It's a parasite can cause this GI tract infection. But for the bacteria, and this thing doesn't show you very well, the one that Salmonella enterica causes typhoid fever. Okay. Oh, by the way, the rickettsia causes typhus fever. It causes typhus. In fact, typhus, not just related to how typhoid fever is caused by a Salmonella enterica. Okay. And I wrote a rickettsia. Remember we talked about rickettsia as a bacteria, cellular bacteria transmitted by tick. It causes typhus. Yeah, rickettsia. I wrote one of my first paper is to use polymerase chain reaction to detect Salmonella enterica. That was 1980, 1990. 1990 is my first paper, and we show that you can detect in the traditional way. When people get salmonellosis, you get like abdominal pain, vomiting from eating raw chicken. And the debate is that, where is the source of infection? It could be in the meat itself, right? or it could be due to the handler, right? And so people always say, "Oh, it's not me, it's the meat," and um, the distributor say, "Oh, it's not in the meat, it's the guy who prepared it." And so we developed. So when I was at the University of Connecticut, we developed a system that is easy. We can check to see where the source of the bacteria is at. Is it in the meat themselves, uh, in the handlers, and so forth? You can read that. Just Google my name and Salmonella. You can come up. All right, so the one that I think that you should focus on is Salmonella, cause typhoid fever, Shigella, cause shigellosis, which is actually causing uh, dysentery, Vibrio cholera, cause cholera, uh, Campylobacter, no, don't worry about that, or Clostridium uh, purgei, don't worry about that one. Okay, so here uh, is very important to note the distinction between bacillary dysentery versus amoebic dysentery. What is dysentery? Um, Dysentery is a condition when a person has abdominal pain, watery diarrhea. Okay, and that water diarrhea or watery stool may contain blood or pus or mucus. Okay? That is dysentery. Now, the bacillary dysentery is caused by these bacteria, Shigella, Salmonella, and E. coli. Now, amoebic, this is amoeba, okay? Amoeba is a parasite, okay? This is a parasite, and the parasite that causes dysentery is Interamoeba histolytica, right? So think of the word amoeba in the name itself, then you know that it is parasitic, okay? Because amoeba is a parasite, not a bacteria. They're much bigger than a bacteria, histolytica. So dysentery can cause either by bacteria or a parasite. In the case of parasite, we call that amoeba, uh, amoebic dysentery. Now, what's the difference between dysentery and cholera? Uh, and here it shows you the difference between dysentery cholera. First of all, the organism that causes dysentery, like Shigella, Salmonella, E. coli, right, or the amoebic Interamoeba histolytica causes dysentery. Cholera is caused by a completely different bacteria known as a Vibrio cholera. Okay, and I told you that Vibrio is a very fast replicating organism. Okay. And in this case, what happened is that they produces a toxin that stimulates the GI tract to produce out a lot of water. Okay, and this water is considered as the rice water stool. Um, and because a person loses a lot of fluid, again, um, their blood volume will decrease. So if you can conquer this, it's basically drink a lot of fluid. Uh, or if you have access to infusion, IV saline continuously, you'll be okay. But people don't drink, and they can develop into a shock. Okay, and we'll see that correspondingly, if your blood volume will decrease, your heart rate will increase. And cholera is very, very typically often seen in an area, say after an earthquake in Haiti, for example. Port-au-Prince might have an outbreak because you don't have access to clean water and you're drinking contaminated water, right? And people do shed these Vibrio in their stool, right? And then contaminated water, you get you drink that, and could lead to an outbreak, an epidemic of cholera. Respiratory tract, if I failed to mention to you earlier, and that is, at some point I must have mentioned to you, the skin, the respiratory tract, the GI tract, or the urogenital tract, all of these area share in common is that they have a surface that is exposed to the outside environment. Right? Even though in the lumen of the GI tract is inside your body, but the lumen is, it still considers outside unless it's invaded into your mucosal membrane. But other than that, I mean, that's why these particular areas tend to have a lot of infection. The skin, the respiratory tract, the GI tract, the urogenital tract, right? It's because they're exposed to the environment. Okay? Unless you have other means to get through the skin, like through a vector mosquito that inject that, or people IV drugs, and they inject themselves with material that contaminated, right? So in some places, they say if you wants to inject yourself with some drug, IV drug user, that's fine. Just make sure you use clean needle. Right? Don't use the dirty needle. And so there are needle change places where you can pick up a clean needle and go have yourself, happy for the next 6 or 7 hours if you can afford it, because it can get very expensive. And don't go there. Don't get involved with drugs. Respiratory tract infections regarding bacteria, Streptococcus pyogenes, and certainly there are many. And I would focus on the organism that are in the red box. Okay. Rhinovirus we already talked about as part of the viruses, but in pharyngitis, which is basically infections here of the pharynx, okay. Streptococcus, the Corin bacterium, diphtheria, you can certainly get vaccinated for this now. Adenovirus, very important for pharyngitis. Croup in chickens or epiglottis, Haemophilus influenza. Certainly they're there, they causes that. I expect you to know all of them. I want you to focus on what is in red box. Pneumonia, which is the lung. The common one is Streptococcus pneumoniae, but some staph infection can cause pneumonia. E. coli, and in fact,